In this video, we're going to solve this logarithmic equation. It has one log with base 16, one with base 4, and one with base 2. And we're going to solve it two ways. I'll look at the first one, the easiest one first, or shorter. And properties of logs again. I won't spend too much time here. I've done this before for other videos. And focus on the two that I'm going to use. So your regular change of base formula is this one right here. Log m to base a is equal to log of m over the log of a. You pick the base. And notice a is the base of the original one here. And then we have this one. This is the one I'm going to use first. Log of m to base a equals 2. And I'm just taking the power a to a power. So in this case I have r. Log m r to base a to the r power. So notice here at base 16 here. Now if I take this base to the second and take this to the second, that doesn't change it. This is still the same value. So 4 squared gives me 16. So there's 16 there. So this is converted. And then for this one here, if I take this base here to power of 4, I can do that if I do it to the x. 2 to the 4th is 16. So I have them all the base I want. So this is in the log to base 16, base x. Actually, I don't want an equals here because I'm actually just rewriting the equation in a different format here. So this will be a plus log again, the base 4 to the second power, that's 16. This is x squared here. The next one is going to be log, and then the base is 2 to the 4th, that's 16. X to the 4th. So now I have all the logs to the same base, and then I'm going to use the property of log that tells me if I have the sum of logs, I can write that as a single expression, and it'll be the log to whatever base we're using, in this case 16, times the product of the value you're taking the log of. So have x, then multiply the x to the second, that's x to the third, then x to the third times x to the 4th, this gives me x to the 7th. That's equal to 7. Now I have here a single log. So using the definition of log, once you have it as a single log, then whatever you have here, that's x to the 7th, has to equal to whatever the base is, in this case 16, taken to this power on the right, that's a 7. So I have that. And then I just solve for x. So I have a 7th power there. So what I'll do here is just take the 7th root of both sides. I'll write it this way. Same thing. So the 7th root of x to the 7th, if I multiply the exponents there, I get 1. So that just gives me x. Same thing here. 7th root of 16 to the 7th. Multiply the exponents. You can do it that way also. You get 16 to the first. That gives you 16. And you can check this out. So just a quick check here. I put a 16 here. The log of 16 to base 16 power is 1. So this is 1. And then for the next one here, if I put 16 here, for the second log is here, log of 16 to base 4, that's going to be 2. Because 4 squared is 16. And then the next one, if I put 16 right here, the log of 16 to base 2 is 4, because 2 to the 4th is 16. So it's just 4 here. 1 plus 2 is 3, plus 4 is 7. There's your check. So we get 16 for that. Now I'll go ahead and use the traditional way. Well, I'm just going to take the natural log. You can pick any base you want here, but I'm going to pick the natural log using the change in base formula. So if I do that for each one of these, will be the log, natural log of x. And then remember, it's whatever you pick. I'm using natural log of whatever the base is. So the base is 16 for this one. I get 16. And then I do the same thing with the next one. Natural log. So this will be natural log of x. And then the natural log of whatever the base is. In this case 4. And then the next one, it's the natural log, then changing the base. Natural log of x over the natural log of the base for that log, which is 2. You get this. And then it's equal to 7. So on the right, we just have a number, so we're not messing with the natural log there. It just stays at 7. And then I'm going to rewrite this. ln of 4 can be written, the 4 can be written as 2 squared. So this would be the same thing as 2, bringing the exponent to the front, would be that. So ln of 4 is the same thing as this. Notice properties of logs allows me to bring the power over here, so that gives me back the same thing. So I'll mark this out this way. And then for the next one, again, I'm going to rewrite that. Natural log of 16 is the same thing as the natural log of 2 to the 4th. It's 2 to the 4th is 16. So I'm going to bring that 4 to the front. This would be 4 natural log of 2. We have that. And then at the same time, I'm going to factor out the natural log. So let me just rewrite this. Got natural log in all of the numerators. So here I'm just going to have a 1 here, a 1 here, and this will be in parentheses, and the natural log would be over here. Natural log of x. Just simplifying it, okay? And so I have natural log of 2, natural log of 2 times natural log of 2, same thing here. So what I do here now is I'll go ahead and multiply through by 4 natural log of 2. So I'm multiplying both sides of the equation by the lowest common denominator. So if I do this, okay, this one has the ln of 2 here. So this is going to be canceled for this one. This will be canceled for this one. And this will be canceled. And this one has the 4 also, so this will be canceled here also. So what do we have left then? Go up here then. This will be ln of x. And then for the first one here, the 4, the ln of 2 canceled. And that just left me with a 1 plus. And for the second one here, ln of 2 canceled. 2 goes into 4, 2, so this gives me a 2 here. Plus. And then for this one here, the ln of 2 cancel. I still have a 4 there. So this is a plus 4 here. And it's just still equal to. And the 7 also gets multiplied by the 4. So that's going to be 28 ln of 2. So then on this one here, then we have, add those numbers up, it's 7 ln of x is equal to 28 ln of 2. And then 7 divides into 28 4 times. So I can simplify this to natural log of x is equal to 7 to 28 is 4. This will be 4 ln of 2. Then I can rewrite this as ln of x is equal to, okay, properties of logs is coefficient, and also make this into a exponent. So this will be a natural log of 2 to the 4th. That's the same thing then as the natural log of 16. Now definition of log. Have it ln of x equal to ln of 16. The base here is e. So this allows me to write this as x is equal to e to that power. It's e to the power of ln of 16. Now we can simplify. have a base e. Log here is e. This is e, this is e. The answer is the 16. So x equals 16. Which of course is the same thing we got using the other method. The only problem with the other method doesn't always work nicely in this case because the powers that you use, you can easily change the 4 to the 16 and the 2 to the 16 by taking the appropriate power to those components. So if the first method doesn't work, this is the general one using the natural log. Thanks for watching. We'll see you next time.